So to find multiplicity, we first, in most cases, we're going to have to factor and find the zeros first. So let's define what multiplicity is and how we determine it, and then we'll get into some examples. So multiplicity it says if R is a 0. So if R is a 0, what that's telling you is you factored and did all your work, and then down at the end you said x is equal to whatever, and that gives you a point. That R is that whatever. So in the if you worked all your example and you got down to the bottom and it said x is equal to 2, then this R represents that 2. R just represents whatever number you found after you got done factoring. So that R represents the x-intercept. So if R is a 0 with even multiplicity, that says even multiplicity. I don't know if you can read it or not. Hopefully I didn't scrunch it too bad. So if R is a 0 and it has even multiplicity, then this is what happens to the graph, or this is what the graph looks like. The graph, and I guess I need a comma after this multiplicity here. The graph touches the x-axis at R and turns around all right. So this is saying if R is a 0, so you factored everything and you got your x-intercepts, that's telling you that this is one of them. So if that number has an even multiplicity, and I'll show you how to determine multiplicity when we get to an example, then the graph will touch the x-intercept at that point, R, and then it'll turn right back around. It won't, so if this is the x-axis, this arm, it comes down and touches, and it turns right back around. So it forms a nice smooth curve. It doesn't go through. That's what odd is going to do. All right. If odd multiplicity the graph crosses the x-axis at R. All right, let's look at an example. Pause the video. I'm about to erase it. Example 1. Find the zeros and give the multiplicity for each. Part A. And let's look at something that's already factored. So we don't have to do a lot of work up front. This example is meant to show you exactly where the multiplicity comes from, or how to figure it out. And then part B, we'll get into the longer examples. So let's say we have 1/2 times x plus 1 times 2x minus 3 squared. All right, so we first need to find the zeros before we can find multiplicity. We first have to determine our zeros, and then we can determine what our multiplicity is. So when we find zeros, we have to set it equal to 0. And lucky for us, this is already factored into this form. So all we have to do is now separate these and set them separately equal to 0. So, so we have 1, 2, 3 things here. So we get 1/2 is equal to 0. And I'm writing this. I'll get to it in y I am in a second. And then you have x plus 1 is equal to 0. And then 2x minus 3 squared is equal to 0. Now we're going to go through here and find our x's. Now does this 1/2 equal 0, what does this mean? Does it mean anything? It doesn't even make sense. So we don't even, 1/2 will never equal 0. There's no variables anywhere to find. So we don't even have to write this. If you have something like that where just the numbers on the outside multiplying to everything else, then it will just go away. So I just wrote it there just for completeness sake, but you don't have to do that. Now let's solve this for x. X is equal to -1. Over here I square root both sides. The square root of 0 is 0. So I'm left with 2x minus 3 is equal to 0. Add 3 over. Divide both sides by 2. Alright, so this is -1 comma 0, and this is 3/2 comma 0. So this is where we stopped in the past because this is all we cared about. But now this is where multiplicity comes into play. We're going to add a little bit on. We do 95% of the work up here, and multiplicity is just 5%. So to find multiplicity of these 2 points, of both of these points, we need to come back to where we first, right before we broke them out into into separated them. So we come back up to this step here. Come back up, and we look right before we broke them out, which was here. And what we want to do is we want to look at the exponents of these things, wherever this point originated from. So this point came from here, which came from here. And the exponent up here, it's not written, but it's implied a 1. Now, is 1 even or odd? 1 is odd, so that means it's odd multiplicity. Pretty simple. You look at the exponent right before you separated them, and if it's even exponent, then it's an even multiplicity. If it's odd exponent, it's odd multiplicity. So this -1 comma 0 originated from here, which it was a 1 up there. So odd multiplicity. Now I'm going to just abbreviate by saying odd multi, or multi, however you want to say it. And get used to just writing out what it does. That way it sticks in your mind. Odd multiplicity, that means it crosses x-axis at -1 comma 0. Okay, why don't you pause the video and give yourself a try on the other side, see what you get. So here's our point, and we need to backtrack and see where it originated from right before we broke it out. So it started here, and we need to come back up to this step right before we broke it out. So this originated from here. Its exponent is a 2. So 2 is even, that means it's even multiplicity. Even multiplicity. That means it touches and turns around at that point. Touches the x-axis at that point and turns around. Touches x-axis at 3/2 comma 0 and turns around. Alright, and that's a lot to write. Touches x-axis at that point, turns around. You can also say tangent. Tangent means the same thing. So you may see that word written. Tangent means the same thing as touches and turns around. All right. Let's look at another example. And I'm going to cheat a little bit here. I'm going to use an example we worked before in the previous lecture. And just so I can skip a few steps. So part B, let's say g of x is equal to x to the fourth minus 4x cubed plus 4x squared. So we worked this one in the previous video, and I want to show it here, but I don't want to go through the whole work process, but I guess I will, just so you have completeness. Alright, so we need to set this thing equal to 0, and we notice each term has an x squared in common, so we factor that out. So same steps as before. And if you recall, this is where I first split these out, but then I said, no, let's keep it like this. The reason is just experience. And you want to make sure that you factor everything as much as you can, and then you start breaking it out into separating. What I mean breaking out is into separately setting it equal to 0. So we can do the AC method on this portion. So x squared, then when you do the AC method, you get x minus 2 times x minus 2. And here's the trick. You have to make sure to know to combine these two. So you get x squared times x minus 2 squared is equal to 2. And then now we can separate these. And I'm going to do that over here. So I get x squared is equal to 0, and x minus 2 squared is equal to 0. So here, x is equal to 0, x minus 2 is equal to 0. So this gives me a point of 0, 0. And this tells me x is equal to 2, so I get 2 comma 0. Now we want to look at where this point originated from. And I guess I'm going to rewrite that top step right here so it's easier to follow. On your notes, hopefully it's just straight down and you can follow easier. So this 0 went here, 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 and here. So we need to come back to this step right here, right before we broke them out into and setting them separately equal to 0. And then I need to look at that exponent right there. So it tells me that 0, 0 originated from this with the exponent of 2. So 2 is even, that means it has even multiplicity. And then same thing for this 2 comma 0. See where it originated from. Came back here, and that exponent is 2 there. So both of these are even multiplicity, so I'm going to say even multi, and the graph is tangent to the x-axis at 0, comma 0 and 2, comma 0. Remember, tangent just means touches and turns around.